This problem is going to be similar to the last in that we're going to find the frictional force used to keep this car on the road. So here's our x and y axis. And we'll come up here and get our forces. And trying to be consistent, we'll use green. So we have a frictional force in one direction, we have a normal force going up, and we have a weight going down. And we'll label those once again so that we can keep them straight. So this is N. This is friction, F, and this is weight, W. So again, our only horizontal force in this whole bunch is the friction, so it's going to have to be the centripetal force. So Fc has to equal friction. And again, our equation is still going to be the same, mv squared over r equals mu mg, because m and w are the same. M's will cancel, and now we need to start putting some numbers in. But we can't, once again, because our velocity is given in kilometers per hour, and we have to have it in meters per second. So we'll do our conversion over here, 95 kilometers per hour. Okay, there are, in 1 kilometer, 1,000 meters. And in 1 hour, there are 3,600 seconds. So we do that conversion and we will get 26.4 meters per second. And that will be our velocity. So we'll come back over here, put our velocity in, 26.4 squared, divided by the radius of the curve, which is given as 85, will equal mu times 9.8. And we'll solve for our coefficient of friction, and we will get 0.84, which is very reasonable for a road.